Hello, good morning. This seems somewhat strange. It's the first time I've presented a webinar like this. I'm sitting in an empty room. Well, I have an audience here of one, young Dominic, who, like many of you, will have filled up his car with petrol on his way to the office today. We all habitually fill up our cars with petrol or diesel fuel, so we think we're familiar with flammable liquids and we know all about them because we use them every day. But the way we're using them there is in a very controlled way, and what we're going to look at this morning is a few more precautions that should be taken around the workplace when we're using flammable liquids to make sure we're safe. So we will stop at the petrol station, normally all serene like this, but every once in a while there's fires even at petrol stations. They have occurred, well-known occasions with just static electricity from clothing igniting petrol around the filler cap, and that has on occasion spread to cause quite serious damage. So we think petrol, diesel fuel we're familiar with, but when you think about it, there's only a relatively few flammable liquids available to the public in bulk, thankfully perhaps. Petrol we've already mentioned, diesel fuel, not to be confused with petrol. I hope there's nobody in the audience today who will be red-faced, but we can't see you because of that. Paraffin, not so much paraffin as there used to be around. Used to be a lot of paraffin heaters. Very few of those now. It's a bit old technology, but it is still available for some uses, particularly in greenhouse heaters and things like that. And those are really the liquids that are available in sort of gallons or multiple litres. We start now thinking about smaller containers. White spirit. White spirit is a particular product made to a British standard. Quite often we buy turpentine substitute, which is very similar indeed in composition, but doesn't have to be made to the strict standard, so hence is quite a lot cheaper. Then we're thinking about lighter fuel. We notice the containers are getting smaller there. We handle lighter fuel, which is very flammable again. And perhaps lastly, and the liquids that come to my mind as being readily available, nail varnish remover, perhaps used more commonly by some of you than others. But then that is for the common flammable liquids. But in industry and commerce, there's a lot of uncommon flammable liquids that can be available in very large quantities in specific industries. We notice there the picture showing containers, drums. Those are empty drums. We'll note that because by the end of this presentation we'll realise that really the drums shouldn't be stored more than 2 high, especially if they're full, and they should all be labelled as to their contents. So these are empty drums, but illustrate the large, very diverse types of solvents that are available in industry, very specialist solvents for a particular purpose. The protection and prevention measures we'll be talking about in the next few minutes set out in a RISCAuthority risk control document, RC55, recommendations for fire safety in the storage, handling and use of flammable and highly flammable liquids. There are 2 further RC documents in this suite of documents. One that deals with the storage in containers other than external fixed tanks, and the last one, of course, deals with the storage in external fixed tanks. And so those 3 documents set out all the measures that should be observed, or the most common ones, in commerce and industry and in the workplace in general. So perhaps to start, we need a little bit of science. We talk about flammable liquids, we talk about some sort of technical measures and technical terms, but perhaps we ought to look at them so we're clear about what we're talking about and all understand them in the same way. So if we have a little bit of flammable liquid in a closed container and we heat it up carefully, showing it being heated there in a sand bath, and as it's heated up, the molecules at the top of the surface will become more and more energetic, and some will come out into the vapor. And when we get a certain amount of fuel in the vapor and introduce a pilot ignition source, then we might just get a flash of flame across the surface of the liquid. The flame won't be sustained, it will just be a flame, and the lowest temperature at which that occurs is called the flash point. If we continue heating, then we get to a level where introducing a pilot flame will result in sustained flame, and that is the lower flammable liquid. If we've got our liquid in our closed container there and we keep heating it above this lower flammable limit, sometimes called the lower explosive limit, then we reach a level at which there's so much vapor there that it's excluded a lot of the oxygen, and there's just not enough oxygen to allow the vapor to burn. And this is the upper flammable liquid limit. And in between the lower and the upper limits, the mixtures of oxygen and vapor will ignite, and you can get a flash, a flame, a sustained flame, or an explosion if it's the circumstances are right. If we just go on heating this liquid without a pilot flame there at all, then we do get to a point where the liquid gets so energetic that it does ignite without any external source of ignition. And this is the auto-ignition temperature where this occurs. Perhaps in practice we're most familiar with this if we leave a chip pan on the cooker and there's no thermostat there, a pan of oil on the cooker. That will heat up until it gets to a temperature where it suddenly will catch light. So these are the four important terms that we need to think about. Flash point and auto-ignition temperature, they are related, and that is something we have to think about, because if we talk about hazardous liquids, everybody tends to think of hazardous liquids relating to their flash point. But the auto-ignition temperature can be equally important depending on the circumstances. So in this slide we can see that the lines there here, for example, petrol, this is the auto-ignition temperature, which is between 600-700 degrees, something like that. And for petrol, the flash point is down here at about 0 or less, somewhat less than 0, depending on the composition of petrol. If we look at engine oil, then not surprisingly, the flash point of engine oil is considerably higher than that of petrol. It's about 200 degrees, but the ignition, the auto-ignition temperature is a lot lower, at only about 300 degrees. So if we have the question of a vehicle with a hot exhaust, and what is the most hazardous liquid that could come into contact with it? Petrol might not be so hazardous as engine oil, or diesel fuel. Diesel fuel is more likely to ignite on a hot exhaust pipe than petrol. So we have to think about our potential ignition sources and the circumstances in which we're using the liquids. Flammable liquids, we've already spoken about those, and that is any concentrations between the lower and upper flammable liquids, we're going to have problems. So that petrol, for example, the vapor pressure of a liquid is we can look up in tables, so that, for example, if we look at the vapor pressure of petrol at about 15 degrees ambient temperature, we'll find it's 3.6%. And that is between the upper and lower flammable liquids of petrol. The lower and upper limits are 1.2 to 7%. Anything in between there, we're going to have a fire or an explosion. and their 3.6% petrol at 15 degrees is going to ignite. We can see that from the tables of figures. I've put acetylene on here as well, not because it's a liquid, it's a gas, but this does illustrate why acetylene is so hazardous, in that its explosive limits extend from 2% up to just about 100%. So that vapor pressure is a valuable, very useful tool to determine whether a flammable liquid is within its explosive limits at the ambient temperature. These explosions, we've mentioned explosions several times. These are powerful explosions. There used to be one ex-army guy who, with a gallon of petrol, could demolish a ex-wartime pillbox. In the photograph we can see here, this is the Italian consulate in London, or rather was the Italian consulate in London. Somebody had gone along there, an Italian had problems with his passport apparently, and had gone down into the basement and poured some petrol in we broke the basement window and poured some petrol in there. His story was he lit it at a time and left it burning, but clearly that hadn't happened. He either hadn't lit it or the rag said he dropped in had gone out. The petrol vapour had spread throughout the building for a couple of hours until the vapour reached the pilot light on the boiler, and then the whole of the building exploded and was distributed over several hundred yards radius. Buncefield, we will all recognise as being a problem with flammable liquids. Tanker was being refuelled. The shut-off valve on the tank wasn't in operating conditions. The fuel continued to spill out until quite a lot had spilled out, and the vapour spread over a wide area until there was a very large explosion, which was even heard at the other side of the channel. So that was a major explosion, and we remember the large fire and the problems that were resulted in firefighting operations following that. So why is a flammable liquid dangerous? We have to think about the flash point, the autoignition temperature, the flammable liquid limits, and something we haven't mentioned, but the ignition energy. For purposes of our thoughts, I think all we need to think about is not necessarily how much energy is there. If there's a potential ignition source, we need to identify it. As I mentioned earlier, just a static spark from clothing has been known to ignite petrol on petrol stations. But if we think of it in purely scientific terms, then each flammable liquid needs a different amount of energy to get it to ignite. So let's move on now. We've talked about these terms, flammable and highly flammable liquids, without really defining what they are. Perhaps at this point we ought to say, when we're talking about a highly flammable liquid, according to the British Standard 60079, that identifies the liquid, defines it as having a flash point less than 32 degrees centigrade. HSE use 21 degrees centigrade for highly flammable liquid. Flammable liquids are defined as having a flash point above 32 centigrade but less than 55 in the British Standard, and the HSE define them as higher than 21 but less than 55. What we have to remember from here really is that these flammable and highly flammable terms are somewhat subjective and have different meanings in different places. If we go to America, then they are different again, and some countries in Europe have different definitions as well, so that we have to make sure that when we're using the terms, we're actually referring to the local definitions. One thing that does arise from here, though, is that everybody seems to be agreed that once the temperature is above 55 centigrade, then the liquids aren't flammable or highly flammable. And this is interesting because the consequences are that diesel fuel has a flash point higher than 55 degrees centigrade. So diesel fuel, therefore, by this definition, isn't a flammable liquid. And the case can be made for diesel fuel tanks not necessarily being subject to a DSEAR assessment. But we'll come on to DSEAR assessments in a minute. Let's have a look at the legislation. The primary piece of fire safety legislation currently is the Regulatory Reform Fire Safety Order 2005, and that refers to dangerous substances. Section 9.2 says that where a dangerous substance is or is liable to be present in or on the premises, the risk assessment must include consideration of the matters set out in Part 1 of Schedule 1, which basically says that you have to do a specific fire risk assessment, which means under the second piece of legislation, the dangerous substances and explosive atmospheres regulations, that a DSEAR assessment has to be carried out. This, again, needs thinking about. A DSEAR assessment actually has to be carried out where there's hazardous materials, but there's no low limit above which an assessment is required. But I think we'd all agree that virtually every building has cleaning materials, and quite often cleaning materials might include small amounts of flammable liquids. But if they're small amounts in milliliter volumes, then really that can be dealt with under the RRO assessment rather than having to have a specific DSEAR assessment. But technically, there is no low limit under DSEAR above which an assessment is required. DSEAR assessments apply to any work of activities involving dangerous substances, not only flammable liquids, all dangerous substances. And they say that measures should be taken to eliminate or reduce, as far as is reasonably practicable, that lovely health and safety phrase, the identified risks. The assessment should identify equipment to be provided and procedures to deal with accidents and emergencies, and requires that information and training is given to employees, and requires that places where explosive atmospheres may occur should be classified into zones. There's normally three types of zones, as zones where a flammable liquid is liable to be present all the time, or is going to be present during normal working practices. There's zones where, in exceptional circumstances, there may be flammable liquids or vapours present. And lastly, those which they're not normally flammable vapours in the atmosphere. But these zones have to be identified in the assessment. The assessment should be reviewed when there are changes to the equipment being used, to storage areas, to the solvents or other materials being used in the process, the procedures that are being undertaken, or the parameters and control measures that are being observed or should be observed, the management of the process and the scale of the operation, and the process times. Now, this question of process times, quite often in laboratories and in small-scale production plant, process times can be quite lengthy, and it may be necessary to have unattended processes carried on, and then these have to be assessed even in more depth. And measures for this are set out in another RISCAuthority document, RC42, Recommendations of Fire Safety of Unattended Processes, which goes into more detail about measures that should be taken when nobody's there. Empty containers, I want to mention at this point, because empty containers are thought to be empty containers and therefore rubbish. They're not. Empty containers are often as hazardous, if not more so, than containers that are full. The reason being that even if there's no flammable liquid in the container, there's quite likely to be vapour there, and it's likely that vapour will have enough oxygen mixed in with it to form an explosive mixture within the container. So that empty cans should be treated exactly the same as full cans, and should be treated with a good deal of respect. Now, there are five basic principles when thinking about protection and prevention measures for flammable liquids. Excuse me, just having a little sip of non-flammable liquid myself. Now these are put together by HSE in an acronym VICES. And these 5 terms of ventilation, ignition, containment, exchange and separation. Perhaps the most important one actually is the 4th one on the list, exchange. In all processes, a good deal of thought should be given to all the flammable liquids which are used in the process and whether any of these can be exchanged for non-flammable liquids. Quite often they can be. For example, the printing industry has had a great deal of success in removing flammable liquids and blanket washes and so on from the processes, and now is virtually sort of water-based. Aqueous inks and so on are used very successfully. So that the exchange is perhaps the most important of these. VICES, however, makes a very nice acronym that people can remember, and perhaps EVIX or something the same wouldn't stick in the memory quite so well. So let's stick with VICES and think about first ventilation. Ventilation. Is there sufficient ventilation to keep the concentration of the flammable liquids below its lower explosive limit? That's what you should be aiming for everywhere the flammable liquids are used or stored, and not just below the lower explosive limit. We're looking really to keep them a maximum of 25% of the lower explosive limit. There should be enough adequate or natural or mechanical ventilation present. Natural ventilation is best because mechanical ventilation, of course, introduces fans and potential sources of ignition, and electrical equipment in flammable atmospheres has to be especially protected to specific standards. Natural ventilation then, where we can, with inlets at a high level and outlets at a low level, so that we can release any dense flammable vapours. Vents should be provided to provide a cross flow of draft. Ventilation should provide at least 6 changes of air per hour, depending, of course, on the flammable liquids, quantities that are there, or the process that are being undertaken in the workplace. So plenty of ventilation required. Ducting should be as short as possible. The ducts should really ideally go straight out from the storage area into the open air outside. You don't want any routes through other fire compartments. As few changes of direction as possible. Changes of direction might introduce corners where there may be a difference in temperature and perhaps condensation of flammable liquids within the ducting. So we want to have the ducting short, of non-combustible construction, and a shorter route to the outside as possible. Not fitted with fire dampers. Ducts shouldn't have fire dampers in them because, of course, if the fire damper closes and there's flammable vapour in the duct, it could build up to produce a flammable atmosphere in the duct. So no fire dampers in the ducts, and they should vent the vapours at least 3 metres away from openings of the buildings and 3 metres above ground level. Obviously, you don't want to vent flammable vapours to the outside and have them coming straight back in a window or doorway. So at least 3 metres from building openings. If there's going to be problems with the environment in some areas or where particularly noxious liquids are being used, then environmental advice should be sought. Next we come on to ignition. All possible sources of ignition. Static from clothing, hot surfaces often forgotten. And a lot of ignition sources are electrical, although we have to think about friction and everything else as well. The electrical equipment, is it protected for use in the area or hazard zone involved? Flames, hot surfaces, heating equipment, electrical equipment, lighting is often forgotten, particularly light switches, Light switches should be outside flammable stores and protected for use in a flammable vapour, where flammable vapour may be present. Friction, static discharges, all potential sources of ignition. Lightning, if it comes to lightning protection, then maybe specialist advice will be required under BS 62305 Part 2, where the means to carry out a risk assessment for lightning is considered in quite some detail. Hot work's always a problem, and contractors are always a problem. If there's flammable liquids and hot work, they definitely don't mix. And so method statements for hot work and hot work permits should be carefully monitored. The use of trucks and vehicles is always a problem as well. If there's going to be lift vehicles in flammable liquid stores to handle drums, for example, then they have to be protected for use in a flammable atmosphere, which means, of course, keeping other vehicles out of the area. The other thing that has to be considered everywhere, of course, is the potential likelihood of deliberate fire setting and reducing the risk of that as far as possible. Containment. Are liquids stored in suitable containers? Metal containers wherever possible rather than plastic containers. Certainly, if liquids are provided in plastic containers, then the plastic container will be suitable for the purpose. Avoid putting flammable liquids in alternative containers. You can have quite some surprises. Some flammable liquids can soften plastics and eat their way through the plastics over a period of time. So keep the liquids in their proprietary containers. Make sure that if there's a spillage, it'll be contained. Prevent spillages in the first place and from them spreading if one does happen by the use of catchment trays or bunds in larger areas. And again, make sure that these nominally empty containers are looked after as well. Storage of flammable liquids should be at or above ground level. A lot of flammable vapours are heavy. They tend to go to ground level, and if they're drains or gullies or work pits in garages, for example, that is where the flammable vapours will accumulate. And there's been numerous examples of petrol vapour in pits in garages being ignited by a light down there which hasn't been protected properly. So dense vapours, prevent them going into drains, and drums and containers should be opened properly, not by puncturing them, which can produce friction or sparks. Drains may occur in surprising places. I was doing a risk assessment of a laboratory only a couple of months ago, and moving a gas cylinder found a drain on the floor, much to the surprise of the people that worked there. You can see the edges of the feet of the assembled people that came to have a look, totally oblivious to a drain being in the middle of their laboratory floor. But that's the sort of things that can be about that need to be avoided and removed. So, contain the flammable liquids. If you're decanting or transferring it, make sure that the correct solvent is being delivered, and it's being delivered to the right container, and the container, the receiving container, is large enough to accommodate the volume required, and that's the biggest reason why spillages occur, and spillages lead to the fires and explosions. Check that automatic shut-offs incorporating overfill alarms are fitted to closed vessels. That was one of the problems at Buncefield. The automatic shut-off didn't work properly, and of course the overfill alarms on large sites like that have got to be monitored in a permanently manned place like the gatehouse. And there's got to be procedures for how to react to an alarm. And ensure that appropriate quantities of non-combustible absorbent materials are available, and staff are trained in how to use them. Catchment areas such as bunds should be provided to contain leakage, not only contain the leakage, but to guard against pollution and contain a possibly flowing fire. If a fire does occur, it's much better to have it contained rather than be flowing down the road. Catchment areas of bunds have obviously got to be of suitable capacity, at least 110% of the largest container in the bund, or 25% of their aggregate capacity. The bunds and base and walls of the bunds must be impermeable to oil and water, goes without saying, and shouldn't be penetrated by any pipes or valves, otherwise there might be some small gaps around the valves or pipes which the liquid could leak. In stores, the whole store could form a bund, and with the door being ramped so that a trolley can be pushed over the ramps, rather than having to have separate containment areas within the store. So that is one practical way of keeping those things safe. We've got a few examples here. The top left-hand corner here, we've got a proprietary flammable liquid storage cabinet. One thing that's worth noting here is that the shelves of these cabinets are often made with welded corners, so they do form trays. So it's worthwhile using them as trays and sort of minimal, like little buns, like containment trays, so that they should be put in the cupboards as trays rather than flat shelves the other way up. In large storage areas, such as this proprietary one on the bottom left here, the whole of the floor is in fact like a large sump, as it were, there. In building sites and other places, then flammable liquids should be put on pallets containing sumps or similar proprietary protection devices, so that if there is a leakage, it is contained. More close up there of drums on the pallets. Unlabelled drums, I'm sure they're empty, but just for the illustrative purposes, of course. Exchange, we come down to exchange. We mentioned that just now. The first thing to do is to make sure that only where absolutely necessary flammable liquids are used, and they can be eliminated wherever possible from the workplace. Separation is the last of the VICE's acronyms, is the storage of liquids separated from other stored materials. Are incompatible materials suitably separated? Are physical barriers present? Most importantly, keep a list of all chemicals with details of their quantities and locations. The fire service will need these details in the event of a fire, so they should be copied and kept at the gatehouse or another easily available place, such as the box for the fire brigade when they arrive. Flammable liquids certainly shouldn't be stored with oxidizing agents or flammable gases, and chlorinated hydrocarbons shouldn't be stored or mixed together with non-halogenated hydrocarbons. All handling of flammable liquids should be in a detached building where possible. If not, it should be in a compartment that provides at least 2 hours fire resistant, ideally accessed directly from the outside and not from within the building. Avoid horrors like this. This was a basement in a university. Everything was dumped down there. Excess solvents were used in occasional experiments were dumped down there, and when they opened it up, there's a horror like this. There's lots of leaking containers, rusty containers, no labels. Avoid anything like that. If you have excess flammable liquids after a particular process is being carried out, then make sure they're disposed of safely or collected from the site by a licensed handler and taken away to safely. So separation, only have the minimum amount of flammable liquids that are necessary in the workplace, perhaps 50 litres stored in the working area at any one time. Really, we're talking about 250 millilitres of flammable liquids are stored in the working area at any one time. Especially in laboratories, apologies for the slide there, we're talking about small reagent bottles, not 250 litres, 250 millilitres. Prevent the accumulation of combustible materials, including rubbish in the vicinity of flammable and highly flammable liquids as well. any flammable liquids that are not needed in the workplace should be stored outside in suitable cabinets or bins that are well labelled, so that if the fire brigade arrive for a fire in another part of the site or another part of the premises, for example, they know where the flammable liquids are. They know what's there. Just a few words as we're coming towards the end now, about enclosed systems. In pipe systems, liquids should be supplied by metered pumps and not be gravity fed. There is a thought, a temptation that if you're using pipe systems, then if you operate by gravity, you're not using any pumps and perhaps eliminating a source of ignition in this way. But it's much better practice to have metered pumps and not rely on gravity for feeds. Pipes should be a stainless steel and be approved to a recognised standard. Certainly it shouldn't be plastic, except in certain special circumstances. Pipes should be marked with arrows to indicate the direction of flows, and hazard markings, especially near hazardous points such as joints, seals, valves and so on. And of course, pipework is metal, so it should be properly supported and electrically bonded. Any pumps, as I mentioned earlier, should be appropriately rated for the area, the hazard zone in which they are installed. In containers, we've already mentioned about not stacking drums to a height greater than 2 metres. If intermediate bulk containers are used, they should be of metal construction, and best not to stack them at all, except in special circumstances with a particular assessment, but certainly not more than 2 high. Lay out stored drums, make sure there's plenty of space to manoeuvre them. If drums have got to be collected or returned to the store, you've got to have aisles at least 1.5 metre wide, and for safety with no dead ends, so that if something does happen, a leak for example, then staff can get out of the store and won't be trapped within a dead end in a sea of drums. Operations such as mixing and transferring shouldn't be undertaken in storage areas. Storage is the storing, handling of these should be outside. Intermediate bulk containers, for those not familiar with what these are, they're large square containers, 1 metre square, nice pallet-sized containers. Some of them have various forms of taps so you can draw straight off the container. Tanks, a word or two lastly about tanks. They should be built on sound foundations. Plastic tanks shouldn't be on piers or supports. They've got to be on fully supported structures, so that places of plastic tanks can deform, so they've got to be fully supported on a raft, concrete raft or something similar. Any supports for metal tanks should at least provide 2 hours fire resistance. Tanks, where possible, should incorporate bunding internally, so that tanks makes them a lot more usable and transportable around site if they carry their own integral bund, as it were. Consider installing foam-enhanced sprinkler installations. That's when tanks are fixed in position. So that our tanks below ground, we've got a tank there on a concrete raft there. It's supported in place so it can't move around. Should be backfilled with pea shingle there, and the manholes will illustrate, in this case, exactly where the tanks are. Certainly any other tanks that are below ground, their points should be easily labelled so they can be seen, so the fire service and others know where the tanks are, especially if any JCBs start digging for other services in the area. So to summarise, flammable liquids, whether we call them flammable or highly flammable, they're dangerous substances, so we have to treat them with respect. Even small volumes, if they escape, a small volume of liquid can be a large volume of vapour, and mixed with air, that can produce a considerable explosion. So even the leakage of a small quantity can be very dangerous indeed. Store and handle nominally empty containers in the same manner as full ones, and when you're carrying out a fire risk assessment, please be aware of your own vices. And I'll say no more of that, so I think we'll draw to the conclusion here. So thank you very much for your attention. I think we may have some questions, and so that we'll look at the questions. Gillian Norman asks, is there a DSEAR equivalent outside the UK? And in Europe and specifically in the USA? I'm sure there is equivalent legislation, because I know our European colleagues carry out similar assessments as we do under DSEAR. It's probably under, well, it obviously is under different legislation, which may be worded differently to cover slightly different areas, so that our DSEAR assessment, whereas it will cover ignition sources and so on, there may be additional items that are being needed in European or indeed in American legislation, so that a DSEAR assessment from the UK might not be able to be taken to the States, for example, and used as a suitable and sufficient assessment for the same flammable liquid in the States as it would be in the UK. So just be aware on that. Be aware of that. Secondly, Jason Murray, plastic self-bunded tanks are commonly accepted. However, they do not provide containment. Should a leak occur from pipework attached to the same? What is your view on the acceptability of plastic self-bunded tanks? As I said earlier, they are safe if used for the liquids and in the circumstances in which they're intended. I think the warning here is to be careful and to only make sure that the plastic tanks are only used for the circumstances in which they're designed. Don't try to take a flammable liquid tank that's being used with one flammable liquid and instead use it with another one, because not necessarily for the flammability of the liquids or the amount of vapor, but of course different flammable liquids have different densities, and so the weight inside the tank may be very different from that for which it's designed, so be very careful. And this raised another point that I haven't mentioned earlier, of course, is using containers for one liquid and then using them for use another liquid. That's something, again, must be avoided. Question here, Martin Hill, thank you. Why use metered pumps rather than gravity feed? I think in metered pumps it's easy to switch the pump off. It's not so easy to switch gravity off, although you can obviously take measures. I think it's for ease of control rather than anything else. If you switch the pump off, supply should stop. As I say, gravity keeps on going. Nicola Phipps, thank you. Are there any concerns with double-skinned flammable tanks, as these seem to be popular? I haven't heard of any incidents that have resulted as a result of the sort of outer bund area becoming full of liquid or contamination in that way, and leakage from them. But again, use them in as the purpose intended, and with these tanks, do ensure that they are kept well away from vehicles and other points where mechanical damage could occur, or where they could be donked by passing vehicles and so on. Question, should IBCs be bunded? I think the answer to that is yes, Sean. IBCs don't have an internal bund. They're just like a drum. We saw a picture just now of an IBC. Basically, it's a rectangular drum with some supporting structure around it, rather than a circular metal drum. So yes, IBCs are best bunded. A lot of IBCs have valves or taps at the bottom for drawing off the liquid. These could leak, and certainly it's a good case for having or keeping them in bunds and on bunded pallets. Is explosion venting still an accepted means of containment should an explosion occur? Yes, but much better to avoid the explosion in the first place. Much better to have venting where you can. There may be some circumstances where venting isn't possible, and so explosion vents of easily disruptible panels, like plastic panels, for example, that can easily break or blow out under pressure, or if more substantial panels have to be used, they should be held in, on tethers so that if the vent does blow, then the panels can't blow out to cause damage or injury to people or things in the neighbourhood. Fine. Well, thank you very much. Thank you for listening. I hope that some of you are still there. In fact, I can see there's some of you still there. So thank you for your time. I'm sure if you come across any other things, please do contact the FPA in due course. Thank you very much. And goodbye, it says. Thank you. Goodbye.